5, 4, 3, 2, 1.
The integrated circuit optimized size, speed, and reliability. By combining the capabilities of a multitude of components onto one device, it enhanced computing power. Because several components were integrated without tangible wires, the integrated circuit could be manufactured at minuscule sizes. And since the components were incorporated onto one chip, they could be purchased at a more affordable price than when they were previously sold as individual parts. The thin film of silicon that surrounded the integrated circuit eliminated deterioration of the electronic components, which drastically reduced the chance of failure in the operation of the circuit. The unique ability of the integrated circuit to minimize size and weight, combined with its nearly unfailing reliability and resistance to space radiation, made it the key component of the Apollo guidance computer, an onboard device that navigates a spacecraft and controls all of its essential functions. A guidance computer must be as lightweight as possible for a rocket to attain the speed necessary to depart from Earth's atmosphere. The innovation of the integrated circuit combined electronic components onto a more efficient, compact, and reliable technological device. Its ubiquitous application in consumer and communications technology has led to the globalization of modern society. In the summer of 1958, Dr. Robert Noin at Fairchild Semiconductor and Jack Kilby at Texas Instruments both faced the same problem: the tyranny of numbers. There were too many electronic components and interconnecting wires to continue to increase the computing power of technology while simultaneously minimizing size. To solve the tyranny of numbers, technology needed to move past the discrete transistor, a device capable of switching electronic signals. Kilby and Noin proposed two ideas. First, all of the previously separate transistors and other components could be integrated if they were placed on one silicon wafer. Second, if all of the components were made out of silicon, the interconnecting wires could simply be printed onto one silicon chip. The combination of these two ideas resulted in the innovation of the integrated circuit. The innovation of the integrated circuit was the primary technological breakthrough that allowed the United States to land a man on the moon. Neil Armstrong's first steps on the moon not only demonstrated the technological development spurred by the Cold War conflict between the United States and the Soviet Union, but they also signified how modern communications were revolutionized throughout the second half of the 20th century. On July 20th, 1969, people around the world witnessed a live video broadcast of one of the greatest accomplishments in history. Neil Armstrong's descent onto the moon symbolized an era characterized by profound technological progress. However, the integrated circuit did not immediately become prevalent in the consumer industry because people did not see a need for personal electronic devices.
And that's one of the reasons that TI came up with this brilliant idea of putting digital electronics into a product that could go down to the store and buy, like calculators. Actually make this a household device and show people that they would benefit from this technology. And, once you make it a consumer device, then you're talking sales in the hundreds of millions.
Although the idea of the handheld calculator was formulated in 1967, a consumer version would not reach the business market until the invention of the microprocessor in 1971. At the time of its innovation, the integrated circuit simply stood as a smaller, more powerful, and more reliable electronic device. But today it has become a universal technology on which the modern world depends. Without the integrated circuit, there would be no communication satellites, no GPS navigation systems, no laptops or cell phones, no personal entertainment devices, no modern military weapons, no large-scale automation, or space exploration. The integrated circuit's pervasive application in nearly every facet of human life clearly illustrates how it has laid the foundation for the technological revolution that now defines our modern society.